Okay, let's go through how to do problem number 5. We're going to convert 5/24 here into a decimal. It converts into 0.113, but we don't know the base, so we have to figure out the base. It's more of an algebra problem. It's really not a big deal. So let me make a new slide. 5/24, that's going to be, I think it was 0.113 in base B. So all we're going to do is expand this 0.113 in base B. The first one after the decimal is in the b to the -1 position. That's 1 over b. The next number, this 1, is in the second position. That's the b to the -2nd, which is 1 over b squared. The last number, the 3, is in the b to the -3rd position, which is 1 over b cubed. This now is just an algebra problem. It's not a nice algebra problem, but it's just an algebra problem. So you can get rid of the fractions by multiplying by the common denominator, which is 24b cubed. So if I do that, I get 5b cubed equals b's 24 b squared plus b squareds cancel 24b plus, that should be a times there. 3 times 24 is 72, and then no b's because they're both b cubed and they cancel. Combine similar terms onto the one side of the equal sign. We get 5b cubed minus 24b squared minus 24b plus 72 equals 0. Sorry, minus 72 equals 0. So there has to be an integer solution to this. B has got to be a positive integers. This is the base now. It's got to be something. So you could try guess and check. You could try graphing it as y equals, and then just use an x instead of the b. But look and see where the graph is crossing the x-axis, and that's going to be the base. You could also try synthetic substitution, but golly, all the numbers that are factors of 72, you'd have to plug those in. So anyway, if you try often enough, 6 works. B equals 6. So this is a base 6 problem. So again, you set it up, and they give you the fraction that goes on one side of the equal sign, and then you just split up your decimal. And it's, if you're doing a base problem like the next one on the previous slide, you always start with 1 over b to the first, then 1 over b to the second, 1 over b to the third, etc. It depends on how many they give you. Just flick back and look at the next one you do. It's the same sort of thing. You're going to go 37 over 60 on one side of the equal sign, and then you're going to bust up this 213. Same way that we broke up the 113 here. And again, it's just going to come down to, can you solve the polynomial mess that you have left over? Okay, good luck.